So this is going to go over some more advanced surface modeling techniques in Rhino. So to get started, one really useful one is cage editing. So this can be used for really any kind of surface, and generally you'll use it when you already have some sort of surface but want to modify it a little bit. So for example, on the right here I have a Taurus. And basically, I might want to make it look like kind of the chair shape to the left of it. And this would be a good time to use cage editing. You could reconstruct this by making a lot of cross-sectional curves and then lofting it, but that'd be a little bit more work. With CageEdit, it works super well anytime you don't need to be perfectly precise. So it'll give you some options. Usually for 3D objects, you want to use a bounding box. That will just kind of surround the object with this customizable cage that you can move around to distort the surface. So use bounding box. I always keep the coordinate system world. And basically the point count just determines how many control points you'll have in each direction of the box. So I'll just leave that at 4. And the degree has to do with the way the surface will distort. So I'll leave that at 3. And I want to edit the whole shape, so I'll keep the region to edit global. So now I can start pulling these points down and in. You can see while I'm cage editing, I actually can't select the object. The only thing you're editing are these points that distort the surface for you. So I'll just take a minute, keep pulling those in, and maybe pull that up a little bit. There you go, so that looks pretty good. And then whenever you're done cage editing something, if you just hit escape, that will get rid of the points, and you can just kind of delete the wireframe it leaves behind. When you're working with a flat surface, it's pretty much the same procedure, but usually instead of using a bounding box, you'll want to use a rectangle instead. And you can just have that match up with the corners of the surface you're editing. And I'll keep the point counts the same. And there you go. So now you can select these. I could, pull up the middle of this surface, whatever you want. So the drape command is really useful for things like modeling topography from contour lines, or for kind of making a smooth surface when you have a geometry you want to approximate. So for this first example, imagine you had all these contour lines. Basically, you'd turn each one into a surface and kind of stack them on top of each other. To turn that into an accurate model of the topography, the drape command will work really well. So basically, you'll select the area you want to drape a surface over. So I'll do this whole area, and I'll leave a little space on each side. And you can see that kind of puts down the sheet on it, which I can take a look at more closely. And that looks pretty good. If you want it to hug the terrain more closely, you'd just change the spacing for that grid. So I'll do that again, but this time I'll use a spacing of 5. That's basically going to make it more precise and hug each of those elevation changes more closely. So yeah, you can see for this one, instead of getting that more smooth slope, it's kind of got like these terraces to it. You can really use this for any kind of shape. Yeah, you could do that. It can be really useful if you want to create a customized surface. So one way to do that is kind of make an array of objects that you can move up and down, like I've done here. So if I wanted to make something that was kind of sticking up in the middle, I could just select some of these, move them up a little bit, and maybe I want this corner to be a little higher. And let's try that. Make the spacing a little bigger. So yeah, you can see at that resolution, you kind of see each of the individual balls. Um, yeah, you can play around with that as necessary. And the drape command will always give you that nice smooth surface. So a lot of times you'll want to work by modifying the things you're using to determine the surface, and then create the draped surface, um, rather than editing the draped surface directly after you create it. So BlendSrf might be really useful for these projects. One spot where I use it a lot is when I have a piece of architecture or hardscape that needs to correct to a more organically curving surface. So for this example, kind of got this staircase, and maybe I need that to correct smoothly to part of the ground. So if I type in BlendSrf, it'll prompt you for the edge of your first surface. So I'll select that. And then the edges of your second surface, you can just go through and select all of those. And yeah, that kind of interpolates between the two and creates this like seamless mesh between them. If you adjust these sliders, it kind of changes the way it's interpolating between the two surfaces you're blending. So you'll kind of have to play with that on a case-by-case basis. Sometimes you'll get something that looks a little weird, and changing those options can fit that, or playing around with these control points can sometimes help fix that. TweenSurface is really similar, but instead of creating one surface that connects the two, it'll show you a certain number of steps as one surface transforms into the other. So that sounds kind of confusing, but I think when you see it, it makes sense. So TweenSurfaces, start with this surface and end with this surface. And you can change the number of steps or surfaces you want in between. So I'll just leave this as 3. All that means is it'll show 3 steps in the transformation from one surface to the other. So you can see in the first one, you've still got those like pretty clear steps, and gradually they smooth out as it transforms into the smooth slope. FilletEdge is a command you can use to take a sharp edge and make it rounded. So basically it does that by inserting an arc around where the edge is. So FilletEdge. You can select any number of edges when you do this, so maybe I'll just do this top face of the cube. And when you determine the radius, basically you're just explaining to the computer how big you want that rounded edge to be. So I'll just leave this at 1. And yeah, that looks pretty good. Chamfer is effectively the same command, but instead of creating a rounded edge, it creates a beveled edge. So I'll show you what that looks like. I'll do the same for edges. And the chamfer distance similarly is just the length of the bevel edge you're taking. So I'll leave that as 1 for now. And there you go. The last command I wanted to talk about is OffsetSrf. You'll use this anytime you have something that's created out of solely two-dimensional surfaces where you want to turn those into something that's actually structural and has depth. So for example, I have this cube, but what I really want is to have a box with actual thicknesses for the walls. So, you could think of this as a little cube house, and right now you can't actually build this. Each of these faces is modeled as just a surface. So if I do OffsetSrf, you can control which way it offsets. So I'll have this one offset outward. You can see the white arrows are pointing out, and I'll have it offset 1 unit. So you can see now, instead of just being a cube made of surfaces. Each of these walls has a little bit of depth to it. You might be able to see it better if I put it in ghosted view. This is actually something you could build now. For that example, I used rounded corners. You could do the exact same thing, but have the corners be sharp instead. Basically the same principle though. Just wanted to show you another example with this shape. This time maybe I'll offset inward just so you can see what that looks like. And maybe I'll do 2 units this time. And there you go. You can see now instead of being a surface, this is actually a solid object.